In this tutorial, we're going to determine the sum of a geometric series, and let's remember what a geometric sequence is. A geometric sequence is a sequence of integer values, typically integers, and we get this sequence of values by starting with an initial value, t1, the first term, or a, and then we repeatedly multiply the terms by a common ratio. And that ratio doesn't change. So we, if the common ratio is 2, to move from term to term to term, we just keep multiplying by 2. A geometric series is going to take that geometric sequence and it's just going to add up all the values. So here we're being asked to find the sum of the first 10 terms of the geometric series, t1 equals 5 and r equals 2. So t1 equals 5. We know that is the a value, and r equals 2, we know that is the common ratio. Okay, so to find the sum of the first 10 terms, we could, say, okay, t1 equals 5, t2 equals, well, the common ratio is 2, so we would take the 5 and we would multiply it by 2, and that would give me 10. And then to get t3, we would go ahead and repeat the multiplication by 2 again, and we would get 20. t4 could be found by repeating the multiplication and getting 40. t5 could be found, again, 80, and so on and so forth. Now, we could go all the way up to 10, so we get t10 equals something, and then we could add them all up. Well, that would be, quite a task, and especially if we were asked, for example, the sum of the first 30 terms. So there must be an easier way, and what we can do is we can just apply the sum of a geometric series formula, which is right here. And all we're going to do is we're going to ask for the sum of the first 10 terms. So we're going to use 10 as the value for n. Okay, so we will say the sum of 10 is going to be equal to, well, we need a, which is the first value, or t1, and in this case it's 5. Then we'll write r to the exponent n. Now r is the common ratio, so here it's 2, and then the n value is 10, and then we're going to subtract 1 from that. All over r, which is the common ratio, 2 minus 1. Okay, so now we can just go ahead and we can start simplifying, and that is filling out what's inside the brackets. So we can say the sum of 10 terms is equal to 5, and I know that 2 to the exponent 10 is 1024 minus 1, all of that over, and 2 minus 1 is 1. Okay, well, looks like we're going to have to 5 times 1023 will be our sum. So the sum of the first 10 terms is going to be 5,115. Okay, so to get the sum of values in a geometric series, I could just, go ahead and list them all and then add them all up, or I could use the formula for the sum, geometric series, and it makes life so much easier. So let's try another question that's a little tougher. Okay, in this question we're being asked to find the sum of the geometric series that is 1 plus 2 plus 4 plus, and then we're not sure how many terms are lying in this gap here. And then we do know we're ending with the term that is 4,096. So just again to convince ourselves that this is in fact a geometric series, we can see that multiplication happened to turn 1 into 2, and in fact it was times 2. And then when we look here again, certainly that multiplication was repeated. So we know that the common ratio here, well, that's going to be 2. Okay, we also know that the first term right here or T1, is equal to 1. Okay, so how do we come up with the sum of this series when we don't know the n value? That is, I don't know what term 4096 is. I know it's the last term, I know it's Tn, but I don't know what exactly the value of n is. I need to know that because in order to find out the sum, I need to specify how many terms I'm adding up. So before I can use the sum formula, I'm going to have to solve for the value of n using the general term for a geometric sequence, which is t at n equals a r to the n minus 1. Okay? So using this information, I can say, okay, well, 4096 is equal to a, which is the first term, in this case 1, times r, which is the common ratio, 2, to the exponent n minus 1. Okay, continuing on, I'm just going to divide both sides by 1, and I get 4096 equals 2 to the exponent n minus 1. If I take the log of both sides, I can see that the log of 4096 is equal to n minus 1 times the log of 2. Dividing, log 4096 divided by the log of 2 equals n minus 1. Well, when I divide those two logs, I get 12 equals n minus 1, or in this case, n is going to equal 13. So that tells me that this term, 4096, is actually the 13th term in this geometric sequence. Using that information, I can now go ahead and apply the sum formula. So the sum of 13 terms is equal to a, well, a is the first term, which is 1, times r, the common ratio, 2. N is 13, so I just need 2 to the exponent 13, and then minus 1. All of that divided by r, which is the common ratio, 2, and then minus 1. This means that the sum of 13 is equal to, I won't write the 1 times, 2 to the exponent 13 is 8,192 minus 1, all of that divided by 1. So the sum of this geometric sequence or series, which starts here and ends there and has 13 terms in it, is actually equal to 8,191. So there's a couple of examples working with geometric series.